A field workshop east of Warsaw, October 1944. The man kneeling in the mud has not slept in 19 hours, and the gear in his hands is broken, not chipped, broken. The teeth on the smaller spur wheel have been peeled back like the husk of a corn cob, and the fragments of 40-some hardened steel slivers lie scattered in the bottom of the final drive housing, mixed with oil that has the consistency of cold syrup because it is 6 degrees outside and the heater has been off for 2 days. His name, in the records that survive, was Obergefreiter. The records do not give us his other name. He had been a tractor mechanic in Hesse before the war, and he understood, the way a farmer understands a plow, that what he was looking at could not be fixed. The teeth had not worn down, they had detonated. The steel itself had failed. He needed a new final drive. The Panther in front of him, chassis numbers stenciled in white paint just under the driver's vision slit, had traveled, by his estimate from the odometer cable, somewhere between 140 and 160 kilometers since the last replacement. Average life, slightly under even. He stood up. He walked to the supply tent where a clerk with frostbitten fingers and a clipboard was tracking the parts inventory for the entire workshop company. He asked for a final drive housing assembly for a Panther Aus A. The clerk did not laugh. The clerk had stopped laughing months ago. He looked at his sheet, ran his finger down a column, looked at another sheet, and said the thing he had been saying twice a day, every day since August. There are no final drives. There has not been a final drive in this depot since the second week of September. There were 6 on order from Mann in Nuremberg. 2 had been destroyed in transit by a P-47. 1 had been diverted to Army Group North. 3 were still theoretically on a rail car somewhere between Munich and Krakow. Maybe. The Panther sitting in the workshop yard was, for all practical purposes, a sculpture. 45 tons of welded armor steel, a Maybach HL230 engine with maybe 700 kilometers left in its life, a Rheinmetall 75mm gun that could kill a Sherman at 2,000 meters, and a final drive that failed at 150 kilometers because the gear-cutting machinery to make a planetary system did not exist in sufficient numbers anywhere in the Reich. The crew had been reassigned to a Panzer IV with a working gearbox and a crack in the turret ring that the previous crew had been told would be welded next week, 3 weeks running. This is the story of how the country that thought it had invented precision engineering lost a war to a country that had spent 150 years quietly perfecting the boring, undramatic, fundamentally democratic idea that one part should be exactly the same as another part. And how that idea, once mocked by German industrialists as crude, mass-market, beneath the dignity of true craftsmanship, turned out to be the single most decisive piece of engineering philosophy in the Second World War. To understand what went wrong on the Eastern Front in 1944, you have to go back to a workshop in Paris in 1785. A French gunsmith named Honoré Blanc laid out the components of 1,000 muskets in separate bins. Locks here, triggers there, hammers in a third pile. He invited the academics and politicians of the city to assemble complete working firearms by reaching into the bins at random. They did. The muskets fired. A young American named Thomas Jefferson was in the audience, and he wrote home about it. He thought the future of warfare, of industry, of civilization itself was sitting in those bins of identical iron parts. But the French government disagreed. By 1806, they had quietly killed the program, on a grounds that Blanc's method made the artisan unnecessary, and an unnecessary artisan was politically dangerous. The skill was buried so completely that when English engineers tried to explain interchangeable manufacture to French officials in 1850, the French had never heard of it. But Americans heard, and Americans, for reasons having nothing to do with genius and everything to do with a thin labor pool, vast distances, and a frontier that broke things faster than craftsmen could repair them, kept working at it. Eli Whitney faked a famous demonstration in 1801 with hand-fitted parts. He gets the credit in textbooks. He does not deserve it. The actual breakthrough happened at the Federal Armory at Harper's Ferry under a quiet and difficult man named John Hall. who by the mid-1920s had achieved something the French had abandoned: rifle locks made by machine in different workshops that could be swapped between guns without a file or a curse from a frustrated armorer. It took another 23 years for the Springfield Armory in Massachusetts to match Hall's standard. It took until 1900 for Singer to build sewing machines that way. It took until 1907 for Cadillac to do it with automobiles. The journey from "this is theoretically possible" to "this is how everything is built" lasted more than a century, and most of the men who did the precision work died unknown. By 1940, this idea had soaked into the American manufacturing economy at a level so deep that nobody noticed it anymore. Standardize, gauge, inspect. Make the tools that make the parts the same. Treat the worker as a capable operator of precise machinery, not as an artisan whose hand feel is irreplaceable. Germany had craftsmen. Germany had brilliant engineers. Germany had Maybach and Krupp and Daimler-Benz. What Germany did not have in 1939 or 1942 or 1944 was the slow, patient 200-year discipline of treating every part as a number on a gauge instead of an object made by a man. That difference would, in the end, decide a war. The Panzer III rolled off the line in 1939 in pieces, and not because anyone planned it that way. Production had been split among 4 manufacturers: MAN in Nuremberg, Daimler-Benz in Berlin, Rheinmetall-Borsig, and Krupp in Essen. The reason had little to do with engineering and everything to do with politics. The Nazi Party had inserted itself into the procurement process with the diligence of a particularly aggressive infestation, handing contracts to firms based on connections, regional employment, and the personal preferences of party officials, with limited regard for whether the firm had any actual experience in tank production. Henschel of Kassel had built locomotives since the early 1800s. Locomotive frames are not tank hulls. The men who knew how to roll a steam locomotive boiler did not necessarily know how to weld a Krupp armor plate. They learned, but they learned in their own way, and the way a Henschel man learned was not the way a man learned, and the gauges they used were not always the gauges Krupp used. In a country with a deep tradition of standardized parts, this would have been managed by a federal armory system whose entire job was to enforce that a transmission housing made in Nuremberg fit, without filing, without grinding, into a hull made in Kassel. America had that body. It was called the Ordnance Department of the U.S. Army. It had been gauging musket parts since before the Civil War. Germany had no equivalent. What Germany had was the Heereswaffenamt, the Army Weapons Office, which issued specifications and then watched, often helplessly, as 5 different manufacturers interpreted those specifications in 5 different ways. The early Panzer IIIs were so manufacturer-specific that mechanics in the field learned to read the foundry mark on a damaged component and immediately know whether the replacement they had in their stocks would fit. Often, it did not. They filed, they ground, they cursed, they cannibalized. This was the army that, in May 1940, drove through the Ardennes and shocked the world. Nobody outside the Wehrmacht's maintenance battalions could see the rot in the supply chain because the campaigns were short. France fell in 6 weeks, Poland in 5. The damaged tanks were collected by rail and shipped back to Germany, where the factories that built them could rebuild them with their own bespoke parts. Then came Russia. Operation Barbarossa was not, in its first weeks, a tank campaign. It was a logistics catastrophe disguised as a victory. The Wehrmacht advanced faster than its supply trucks could follow. The Russian rail gauge was wider than the European standard, which meant every kilometer of captured track had to be torn up and relaid before German trains could use it. The roads, where roads existed at all, dissolved into mud in autumn and froze into ankle-breaking ridges in winter. Tank breakdowns ran roughly 50% higher than they had in France. The German maintenance system, inherited from the short campaigns of 1939 and 1940, assumed damaged tanks could be loaded onto rail cars and sent back to Germany. By August 1941, this assumption was an active joke. There were no rail cars, there was no track, there was no Germany within reach. A tank that broke down outside Smolensk was not going to Berlin for repair. It was going to be fixed where it stood, or it was going to be abandoned, or it was going to be cannibalized for parts to keep another tank running. The Wehrmacht did what it had to do. It built field workshops. It created Werkstattzüge, workshop platoons, embedded inside the Panzer battalions. It improvised armored recovery vehicles. The Berge Panther, a Panther hull stripped of its turret and fitted with a winch and a crane, was born from this need. It was an engineering response to a logistics failure, and like much of German wartime engineering, it was magnificent, expensive, and far too complicated for the scale of the problem it tried to solve. Because here was the thing the field workshops could not improvise: parts. The Werkstattzüge could weld armor, they could rebuild engines, they could change tracks and torsion bars. What they could not do was conjure a final drive housing for a Panther out of a forge that did not exist. They could not turn a 60 kilogram per millimeter cast steel housing on a lathe that the workshop did not have. They could not mill the internal teeth of a planetary gear because no one in Germany had built enough of the slotting machines required to make those gears in volume. A general staff officer wrote, in language that is unusually frank for a German army document, that the composition of the vehicle fleet had become unprecedentedly diverse. Makes and models from across Europe, captured French Renaults, Czech 38Ts, Italian leftovers, German Panzer IIs and IIIs and IVs in various subvariants, each with its own peculiar requirements. A spare parts depot trying to support all of this was not a depot, it was a chaos. By contrast, when an American Sherman in Normandy threw a track in July 1944, the workshop platoon could pull a track section from a Sherman built in Detroit by Chrysler, or in Lima, Ohio by the Lima Locomotive Works, or in Berwick, Pennsylvania by American Car and Foundry, and bolted directly to a tank built by the Pressed Steel Company. 11 different American manufacturers built the M4 Sherman during the war. The parts interchanged, all of them. The Germans built 5,663 Panzer IIIs across multiple variants. The Americans built nearly 49,000 Shermans across 11 plants. The number was not larger because America had more steel, although it did. It was larger because America had spent 150 years learning how to make a part in Detroit that fit a tank built in Pennsylvania, without filing, without fitting, without the unique knowledge of a craftsman who happened to be standing in the right factory at the right time. If there is a single mechanical component that explains why Germany lost the tank war, it is the Panther's final drive. A final drive, in plain language, is the last set of gears between the engine and the road. It takes the high-speed rotation of the transmission output shaft and steps it down into the slow, torque-heavy rotation needed to turn the drive sprocket that pulls the track. On a tracked vehicle weighing 45 tons, the loads passing through the final drive at the moment of a hard pivot turn are difficult to describe in language that doesn't sound like exaggeration. They are not measured in horsepower, they are measured in the structural collapse of hardened steel. The original MAN proposal for the Panther called for an epicyclic gearing system, what an engineer would call a planetary gear, similar to the one used in the Tiger I. A planetary system distributes load across multiple gears arranged around a central sun gear, so that no single tooth on any single gear has to absorb the full force of the engine. Tigers, with this system, were unreliable in many ways, but their final drives were not the catastrophic weakness. Germany, however, did not have enough of the right gear-cutting machine tools. Specifically, it did not have enough slotting machines to produce the internal toothed gears a planetary system requires. The Tiger could afford this exotic machinery because Tigers were built in small numbers, about 1,350 vehicles, hand-built in the equivalent of a precision watchmaker's shop. The Panther was supposed to be the new mass production tank. 6,000 were planned, then more. Karl Otto Sauer, the Reich's chief director of armament and war production under Albert Speer, pushed simplification through over the objections of the original designers and several officers who could see, with their engineers' eyes, what was about to happen. The planetary gear was scrapped. The Panther got instead a double spur gear final drive, two big spur gears, simpler to make, brutally inadequate for the loads. The double spur design concentrated all the engine's torque on a small contact area between two gear teeth. Worse, alloy shortages, particularly of nickel and molybdenum, which Germany had to import, forced the substitution of inferior tempered steels. Worse still, the housing was made of cast steel rated at 60 kilograms per square millimeter, with shrink holes occasionally welded over, and the housing then annealed in the hope that it would not crack. The housings were initially too weak. The outer mounts bent under the pull of the track. They were eventually replaced with stronger housings, which still failed, only slightly less often. The result was a tank with an average final drive lifespan of 150 kilometers, 93 miles, a Sherman from Fort Knox to Louisville. A Panther was, on average, a single road march away from a workshop. And the workshop, increasingly, did not have a replacement. When the failure happened, it was not gentle. Crews described the sound as a rifle shot followed by a metallic shriek, then the shudder as the tank lost drive on one side and slewed to a stomp. To replace the final drive in the field required, in the words of a wartime German report, an all-day job. The driver's compartment had to be disassembled, the transmission had to be lifted out, by a tripod beam crane if one was available, or by a Berge Panther pulled in for the purpose. A Sherman crew, working without a crane, could swap a final drive in roughly an hour because the Sherman's powertrain had been designed from the beginning around field replacement, with crew-serviceable parts and a single reservoir of oil shared across the whole drive system. By the end of 1944, spare parts production for the Panther had collapsed to roughly 8% of vehicle production. Field workshops were no longer repairing tanks, they were cannibalizing tanks. A Panther with a broken transmission would be parked, stripped, and slowly disassembled to keep 3 other Panthers running until they too broke and were stripped in turn. The reports use the German word ausschlachten, which is the same word a butcher uses for a carcass. 3,000 miles from the Eastern Front, in Warren Township, Michigan, Chrysler had built something that did not exist anywhere in Germany. The Detroit Arsenal Tank Plant. Built in 1940 by the Chrysler Corporation under contract to the U.S. Army, designed to withstand aerial bombing, though no German bomber ever came within 2,000 miles of it, and operating around the clock by April 1941, it was producing complete M3 Lee tanks before the building was even finished. By 1942, it was rolling Shermans. By the war's end, it had built more than 22,000 tanks, including nearly every Sherman fitted with the Ford GAA V8 engine, every M4A3E8 Easy 8 with the high-velocity 76mm gun, and the post-war M26 Pershing. If you walked the Arsenal floor at noon in 1943, you would smell 3 things at once: the cutting oil from the milling machines, the ozone of arc welding, and the faintly burnt iron tang of armor plate being rolled. You would hear the rivet hammers, though by 1943 most of the riveted construction had given way to welding, and the older men in the plant could still tell you, by ear, which welding rod was being used at which station. You would see women. Thousands of women on every line, doing every job, including jobs that had been considered impossible for women in 1940 and were taken for granted by 1943. Rosie was real, and Rosie was not just a poster. Rosie was a woman from Hamtramck whose husband was somewhere outside Casino. She had calluses on her right palm from a die grinder. She knew, by feel, when a torque wrench was reading slightly off. She built the suspension bogies that held the Sherman's vertical Volute spring system to a tolerance of plus or minus 0.03 of an inch. They fit a tank built 6 months later in Lima, Ohio, without modification. This was the secret. Not the women alone,
Not Detroit alone, not the steel alone, though America made an enormous amount of steel. About 67,000 tanks worth was diverted to naval construction during 1942 and 1943 because the country could afford the diversion. The secret was that the parts the women in Hamtramck made fit exactly the parts the men in Berwick made, which fit the parts the workers in Butler, Pennsylvania made at the American Locomotive Company plant. A Sherman M4A1 with a small hatch hole from any of the 11 manufacturers had parts that interchanged with no modification needed. The cosmetic differences, a slightly different hinge here, a built-up antenna mount there, Chrysler's distinctive drive sprocket, were superficial. The parts that mattered, the parts the war turned on, were the same. This had been built into the design from the start. The U.S. Army Ordnance Department under General Gladian Barnes insisted on it. Standardization was not an afterthought, it was the project. The Sherman was not the best tank of the war. Many German tanks could outshoot it. The Panther's frontal armor was thicker, the Tiger's was much thicker. None of that mattered as much as the fact that a damaged Sherman in a field workshop near Bayeux in July 1944 could be repaired with parts from a depot in Cherbourg or a tank stripped 200 yards away and be back in the fight by morning. The time spent on engine maintenance was carefully measured by the Army. An M4A3 with the 4 GAA averaged 110 hours to service the engine. An M4A4 with the Chrysler Multibank, 5 automobile engines bolted together onto a common output shaft, an absurd-sounding arrangement that worked, averaged 45 hours. The Panther's Maybach HL230 required engine replacement on average every 1,000 kilometers, a job that took 8 hours and required a tripod beam crane or a Berge Panther. A Sherman crew could keep a Sherman running with a wrench, a manual, and the right part in a crate. A Panther crew, by 1944, increasingly could not.
Return to the field workshop east of Warsaw, October 1944. The Obergefreiter has gone back to his bench. There is no final drive. There will not be a final drive. The Panther is parked at the rear of the yard with 3 others in the same condition, and a 5th is on its way in, towed by a Berge Panther with the same problem. The workshop company commander files his report. Under tanks operational, he has written a number. Under tanks under repair, he has written a larger number. Under tanks awaiting parts, he has written a much larger number, and beside it in the margin he has written in German a single word that translates roughly as indefinitely. Across the room, the parts clerk is on the field telephone. He is calling the regimental supply officer, who is calling the divisional supply officer, who is calling someone at Army Group, who has been calling Berlin for a week. Somewhere in the chain, a junior officer has noted that the Maybach engine factory at Friedrichshafen has been bombed and is at a complete production stop. The notation is from August. It is now October. Meanwhile, on the other side of the broken tank, 2 privates are using a torch to cut out a damaged torsion bar. The Panther's interleaved road wheel system, a brilliant German engineering solution that distributed the tank's weight beautifully across rough terrain, required that they unbolt and remove 3 road wheels just to reach the bar that had broken. In winter, those interleaved wheels could clog with mud and rocks, which then froze solid overnight, locking the suspension. In the spring and fall mud of the Eastern Front, this happened regularly. There are photographs of Panthers immobilized at dawn, their crews hammering at chunks of frozen earth wedged between road wheels while a Soviet artillery battery zeroed in. A Sherman had no interleaved wheels. A Sherman had vertical volute spring suspension and later HVSS bolted to the outside of the hull. When a unit hit a mine and ripped a bogie off, the workshop crew bolted on a new bogie. 45 minutes if the parts were close at hand, 2 hours if they had to dig in the depot. The repair was crew serviceable. It happened in the field. The tank was back in the fight by lunchtime. This is the contrast that decided the war. Not the size of the gun, not the thickness of the armor. The simple, undramatic, fundamental question:
When something breaks, can your crew fix it with a tool and a part? For the Sherman, the answer was almost always yes. For the Panther, the answer was almost always no. By 1944, German Panzer regiments routinely reported availabilities between 50 and 75%. American tank battalions in the same months often reported availability above 90%. A division that lost 15 tanks on Monday had 15 replacements by Thursday. In the German case, it had 2, and 3 of the 15 damaged tanks would be fixed by Friday, and the remaining 10 would sit in a workshop yard waiting for parts that were stuck in a rail yard outside Krakow, and that would, in many cases, never arrive.
Sergeant Lafayette Poole of the 3rd Armored Division, War Daddy Poole, a Texan from Odom, fought through Normandy and into Germany in a Sherman M4A1 named In the Mood. By the time he was wounded in September 1944 near the German town of Münster, his crew had fought in 3 different Shermans, replacing knocked-out tanks with new ones almost without interruption. The 3rd, In the Mood, had a 76mm gun fitted in the field as part of a depot rebuild. The fact that this rebuild was even possible, that a Sherman with a 75mm turret could be fitted with a 76mm turret pulled from another tank, depended absolutely on the standardized turret ring that every American manufacturer had built to the same specification. Poole's first knocked-out tank was hit by a German anti-tank gun outside Mons, Belgium. Crew bailed out, Sherman was towed to a workshop. Poole was assigned a replacement within 36 hours, drawn from a depot pool of pre-positioned tanks delivered by Liberty Ship and Railhead. He did not have to wait for parts. He did not have to wait for a specialist crane. He had to wait for the time it took a clerk to assign him a new vehicle. Across the line, Hauptmann Otto Karius of the 502nd Heavy Panzer Battalion, a small, quiet, almost scholarly man who would become one of the highest-scoring German tank commanders of the war, fought Tigers in Estonia and Latvia in 1944. His unit's records, which he later published in his memoirs, are an inventory of mechanical heartbreak. Karius writes about Tigers immobilized by transmission failure on the road to the front, about crews abandoning tanks because there were no spare parts, about being told by maintenance officers that the next replacement Tiger was 3 months away. His own Tiger, on more than one occasion, was the only operational tank in his company. He destroyed Soviet 34s and JS-2s with the precision of a pistol shooter on a range. And then, after the engagement, he watched his crews tow other Tigers, his comrades' Tigers, off the battlefield because their final drives or transmissions had failed mid-engagement. A Russian sergeant named Alexander Oskin in a T-34-85 ambushed 3 Königstigers near the Polish village of Ogladov in August 1944. The Tigers were, on paper, immensely superior. They had thicker armor and a longer-ranged 88mm gun. But the German company had been given only a few days to train on the new vehicles. The final drives were already showing wear from the road march to the front, and the ground was soft. 2 Tigers bogged down. Oskin, hidden in a sunflower field, killed 3 of them with a tank smaller, lighter, and individually inferior to anything the Germans were fielding. He won not because his tank was better. He won because his tank moved when he asked it to move, fired when he asked it to fire, and did not require a tripod beam crane every 200 kilometers. In a war fought across thousands of kilometers, German precision engineering of a small number of magnificent vehicles was not enough. There were not enough magnificent vehicles. The vehicles broke. The parts to fix them did not arrive. There was a moment in early 1943 when senior German engineers understood exactly what was happening. The records of the conferences are preserved. Dr. Wiebeke, the chief design engineer for MAN, sat in a meeting in February 1943 and proposed standardizing components between the Panther II and the Tiger II: the steering gears, the final drive, the road wheels, the transmission. The idea was to share parts, to build one set of components in one set of factories using one set of gauges and use them across multiple tank designs. It would have rationalized the parts inventory. It would, perhaps, have meant that a final drive sitting in a depot near Krakow could fit either a Panther or a Tiger II, doubling the effective availability of that part. The proposal was discussed. The proposal was studied. The proposal was, in the German way, refined to perfection on paper. And then the proposal was, like so many other proposals in the wartime German tank program, overtaken by the reality of bombing, scarcity, and the political infighting that ran through Speer's armaments ministry like a fault line. The Panther II was never built in production quantities. The standardization remained on paper. The tanks at the front continued to have their own bespoke parts, and the parts continued to fail to arrive. Meanwhile, Karl Otto Sauer, who had pushed simplification of the Panther's final drive over the objections of the designers, was not an engineer. He was a Nazi Party administrator. He understood production schedules. He understood the political requirement to deliver tanks in quantity. He did not, in any deep sense, understand the difference between a planetary gear and a double spur gear. And the men who did understand were not in a position to overrule him. This is what happens when a state insists that political will can substitute for industrial reality. The double-spur final drive failed not because German engineers were stupid. It failed because the people in charge of the decision were not engineers, and the engineers who were available were not in charge. Across the Atlantic, at the Detroit Arsenal, the production lines never paused. They ran 3 shifts. Trains arrived hourly. The parts came in crates marked with the universal nomenclature of the U.S. Army Ordnance Department. They fit.
The Panther final drive problem was, in some sense, never solved during the war. The improvements made in late 1944 helped. Better gear teeth, better lubrication, stronger housings, but the basic flaw remained. And the flaw was not metallurgical. The flaw was systemic. Germany had built a tank that required a kind of parts supply system Germany did not possess. After the war, the Bundeswehr, the new West German army, was equipped with American M47 and M48 Patton tanks, manufactured to American interchangeability standards. When West Germany finally built its own post-war tank, the Leopard 1, in the late 1950s, the design philosophy was different: modular, standardized, field-serviceable. The men who had walked the field workshops of the Eastern Front and watched Panthers turn into sculpture for want of a final drive housing had become senior officers and engineers in the new army, and they had not forgotten. The Detroit Arsenal kept building tanks. It built the M48 Patton. It built the M60. It is still in operation today, run as the Detroit Arsenal Tank Plant by General Dynamics Land Systems. The Sherman tanks made there fought, in updated form, in Korea, in Yugoslavia, in dozens of post-war conflicts. Some of them fired their last rounds in anger as recently as the 1980s. The American Locomotive Company, ALCO, builder of nearly 2,700 Shermans at its plant in Schenectady, New York, went out of the locomotive business in 1969. Baldwin Locomotive Works, another Sherman manufacturer, closed. The Lima Locomotive Works disappeared into mergers. The vast American railroad industry that had been retooled for tank production turned out, after the war, to have been retooled out of its own future. Diesel locomotives were the future, and the steam locomotive companies that had built tanks were exactly the wrong companies to build them. The railroads helped win the war and then died of their own success. In Germany, MAN survived. It builds trucks and diesel engines today. Henschel of Kassel survived too, for a fashion. Its rail division was absorbed and reabsorbed through Thyssen-Henschel, ABB, Daimler-Benz, Bombardier, and finally Alstom, the French company that today builds locomotives in the same Kassel works that once built Tigers. Maybach, the engine maker whose HL230 powered the Panther and the Tiger, became a luxury Mercedes-Benz brand. The same name that once meant a 23-liter V12 in a 45-ton tank now means a luxury sedan. Whether that is a fall or a kind of dignity is up to you.
Return, one last time, to the workshop east of Warsaw. The Obergefreiter is finishing his shift. He has wrapped the broken final drive housing in a rag and set it on a workbench where someone with more authority than him will eventually decide whether it is worth shipping back to the factory in Nuremberg for analysis. The decision will not be made for several weeks. By that time, the workshop will have been moved 60 kilometers west, and the housing will have been left behind, in the mud, with 100 other broken parts that there was no time to ship and no one to ship them to. The Panther it came from was destroyed by its own crew during the retreat the following March. They drained the oil, set the engine running on full throttle, locked the throttle linkage, and walked away. The engine seized. The tank was abandoned. A Soviet recovery team found it in May 1945 and judged it not worth recovering. It sat where it had been parked for another 23 years until a scrap drive in 1968 cut it apart for the steel. 45 tons of steel, a Maybach engine that had been the most sophisticated piece of automotive machinery in Europe in 1942, a 75mm gun built by Rheinmetall, armor plate from Krupp, and one cast steel housing made of the wrong alloy in the wrong shape with the wrong gear inside it that turned all of it into a sculpture. There is a photograph in the National Archives taken in February 1945 in the Saar Valley of an American maintenance crew working on a Sherman. The tank is jacked up, the right side track has been removed. A young soldier, he can't be more than 20, is holding a brand new bogie assembly, fresh from a crate, and he is grinning. The bogie was made in Berwick, Pennsylvania. The tank was built in Lima, Ohio. The bogie fits the tank. It fits the way every bogie made for every Sherman by every American manufacturer fits, because for 150 years, in a slow and unglamorous and largely uncelebrated tradition, Americans had been working out how to make a part in one place that would fit a machine in another. The photograph is not posed. The soldier is grinning because his sergeant has just told a joke. The bogie is just the bogie. It is not the point of the picture. It was not even to the men in the picture particularly remarkable. It was just a part, in a crate, from a depot that fit. They expected nothing else.
The Germans in 1939 expected nothing else either. They expected better. They had Krupp and Daimler and Maybach and Rheinmetall, the great names of European industry, and they had a doctrine of engineering excellence that prized the individual artisan and the bespoke solution. They believed, with the full force of national tradition, that what they made was simply better than what the Americans made. They were not entirely wrong. Many of the things they made were better. A Panther's frontal armor was better. A Tiger's gun was better. A Maybach engine, when it was running, was a remarkable piece of machinery. But none of it mattered in the end, because when the Panther's gear teeth peeled back at 150 kilometers, there was no replacement gear, in no depot, on no rail line, that fit. And in a war fought across the Russian steppe and the Polish plain and the Norman bocage, that single fact, the absence of a part where a part should have been, was worth more than all the armor and all the guns and all the brilliant engineering the Reich could field. The American system of manufacture was not glamorous. It had no Krupp, it had no Maybach. It had Springfield, Massachusetts, and a man named John Hall in a federal armory in Virginia in 1826, and it had 100 years of women and men in Connecticut and Pennsylvania and Ohio and Michigan slowly, patiently working out how to make one part exactly the same as another part. It was the most undramatic kind of triumph imaginable. It was the triumph of the gauge over the artisan, of the system over the genius, of 1,000 identical bogies in 1,000 identical crates, each one perfectly ordinary, each one indistinguishable from the next. The Germans had laughed at it when they thought about it at all before the war. They thought it was crude. They thought it was the manufacturing of a country that did not really understand engineering. By the autumn of 1944, when the Obergefreiter knelt in the mud east of Warsaw and held the broken housing in his hands and understood that no replacement was coming and that the tank in front of him was, in any practical sense, finished, the Germans had stopped laughing. There were no gears. There was only the snow and the Panther and the long road west.